the customer satisfaction index of 8 plus. We have NPS 35. We have 2.9 terabits per second of streaming during the peak hours. We have 100K unique users from our web and mobile clients. So this is the small journey of Swisscom TV. Still now going to tell it about Swisscom TV. We started in 2006 when we launched something called Blue in TV, which was like a part of like Swisscom TV. We started in 2009, the HD channels, 2010, TV Air solution. Then in 2011, we were already the market leaders in the digital TV business. In 2012, we launched Replay TV. The Replay TV is like, you know, you go back into the days, months, of course, not months, of course, and watch the TV. Then in 2013, we reached 1 million customers. Then we have Teleclub Play. And in 2014, we launched something called TV2. And this was the TV which was fully developed in-house, or kind of all the components of the TVs were built here. So this was our TV2 project. And this was the time where we decided that we build our TV with the best of the breed products out in the market. Till then, we used to have something called Microsoft Media Room. This was the TV solution we used to have. And then we launched our TV2, and at a later phase, 2017, we phased out the media room completely. We became the market leaders in the TV business fully in 2015, and slowly we, got into other things than just TV, than the streaming TV signals. We became the biggest content providers for VOD, Teleclub Play. So you have content which is being the United States played, and you have it the very same week in the Swiss languages in Swisscom TV. 2016, we launched the voice search. So voice search was like kind of, you press a button here and then you can say, go to SRF, for example. So this is what we did in the past couple of years, and now I'm going to shortly show you.
Das ist sie, Ihre neue Swisscom Box. Sie legt Ihnen das ganze Content-Universum zu Füßen und findet Ihr persönliches Lieblingsprogramm aus Hunderten von Quellen. Sprechen Sie einfach mit ihr. Sagen Sie, hey Swisscom, und los geht's. Hey Swisscom, schalte den TV ein. Mach leiser. Mach lauter. Gehe zu SRF 2. Starte Netflix. Suche nach Tatort. Sport, Krimi, Filme mit Brad Pitt. Sie kann aber noch mehr. Ihre Lieblingsmusik abspielen. Ihr Licht bedienen. Oder einfach sagen, wie das Wetter morgen wird.
Den ganzen Tag bewölkt.
So schön einfach. Ihre neue Swisscom Box mit Voice Assistant. So viel mehr als TV.
All right, that's all about Swisscom. I'm not going to talk more about Swisscom, otherwise the Elastic guys are going to kill me. All right, so this is what we did with for our Elastic, for our media cloud platform. This is what I'm going to talk further now. So we had the hardware, which are the CPU, memory, storage, network, and all sorts of things connected. On top of, we had a virtualization layer, OpenStack or whatever. And on top of that, we had the virtual CPU, virtual memory, virtual storage, virtual network, and so on and so forth. And on top of that, we built our subsystems. Let it be the subsystem which is responsible for playing TV, or like storing the videos, or be it, recommendation engine or whatever. So this is what I just tried to put it as subsystem 1 to subsystem N. And on top of that, we had an orchestration layer, which was kind of orchestrating all these things. And on top of this, we had the business input coming from our, biz DevOps team. And this was the layer which we had to build up at the end of the day with this new concept. I mean, it doesn't mean that we did not have monitoring at all. We had a lot of monitoring tools. And focus I'm going to do right now is building up the monitoring and the monitoring services on top of this layer. You know, this is the slide we all know. Like, we had all type of monitoring tool. The network people, they are more than happy to have their own monitoring tool. The hardware people, their own monitoring tools, set of monitoring tools. Application people, their own monitoring tools. The problem was like, the person who is like very new to the team, or like who does not have an understanding deep into one of the components. It was very difficult for him to get a big picture with these tools. And overlapping, consolidated situation was something which was difficult for them to do. So this is what I also have it put in on this next slide. The networking people had their own network slides, network monitoring tools, storage, So what we tried to do was build up something with all those tools, of course, or at least we tried to get rid of the tools which didn't make any sense. So the infrastructure people, we took their monitoring matrices, logs, events, pushed it up. Container people, we said we did the same. Network people, we did the same. Application and the service people, we did the same. We tried to extract or like push or pull even, the things into an aggregated layer. And from this aggregated layer, what we tried to do was we did a correlation. And further, we did the consolidation and dashboarding and alerting. And what we are right now, doing is the machine learning and AI on top of that. And to do this, it's another kind of visualization where I was trying to put the different things. We had hardware components, bare metal components. We have OpenStacks. We have applications which push the matrices, logs, and we also had a lot of custom checks actually. So it was not just about logs and matrices. It was also a lot of custom checks we used to do. Because in TV we don't have a lot of things which is like ready to use. You have to do your own checks sometimes. And this we did in this layer, and this is the place where we used Elastic actually, right? So that's what we did, and we further built up a lot of dashboards. We created a lot of alarms whenever it made sense, and there we use Sensu, not Elastic, but of course, Elastic was the base where we did this aggregation and correlation. I'll quickly run through a couple of dashboards, of course, to give you an idea about how we did our dashboardings. We primarily did our dashboardings with Vega, even though Kibana is a great tool, but Kibana gives also the possibility to do a lot of things with Vega. What we tried to do was like kind of a high-level dashboarding of the components, or the subsystems and systems, and so on and so forth, And you had the possibility to further drill down from this high-level view into something further. Looks just fancy, so that's why I just put it in the slide. Doesn't have to be this. But this is again something which again, when you drill down from one of the subsystems, you have a view which shows all the components which are in this subsystem. This is a simple example where we have like a couple of services which is scaled across the scaling groups, which you see like SG1, SG2, and so on and so forth. And further, there are a lot of checks done to see the healthy status of this. This looks crazy. Someone was telling you it's like some Anyway, so this is the view which people mostly use. It's like, you see the real problems actually, So we call it like average response time is a bit high in one of the scaling groups or one of the components, or there are some kind of warnings from the HTTP calls, and so on and so forth. So this is the view we have built. This is again another view we have where we try to drill down into the server level checks, to see what is the amount of HTTP 400s thrown from this set of servers, which is currently in a warning state, but the rest of the servers are currently in a good state, So again, another visualization where we not only have the checks on the servers, but it's also on the different services. So checks are not just done on the servers, but on the services as well, and so forth, and so on and so forth. And some more screenshots, the very simple timeline graphs. This again another thing which we did. We tried to, dashboard the different streaming components or virtual transcoders. And again, here we had an idea about the different type of transcoder in the different availability zones, and if they are in a faulty state, in this one dashboard. All right, so there we did a lot of things. We collected quite a lot of logs, data, matrices, events, all sorts of things. So we now had to do the next step, which was like learn from all these things. The machine learning, AI, this was the buzzword. So what we tried to do there was like, our team had a lot of very efficient engineers who were very good in telling, hey, when this happens, we have this problem. This was like in the minds of like the brains of a couple of great engineers. That philosophy that we said, let transistors do the work, not the human. And what we tried to do there was like we introduced the human intelligence and the machine learning to build something called AI Ops. And this is a journey we are on. We have done something, but we still have a long journey to go. I'll shortly go through some of the things what we have done. The anomaly detection, it's a very simple thing. We also did it. We also did it for the average response time on the different components, the increase in the error rates, infrastructure, CPU memory usage, these kind of things. Whenever we found some anomalies, we kind of try to, raise it, push to the right people who are in the team who are responsible for that. What we also did was like the dynamic baselining. So we defined some models which goes to the baselining for the different components, different services, different servers, and the scaling group and so on and so forth. So which means that if there is some increase in the CPU utilization, then it's alerted. But it also means that if one of the services is in a very faulty state when compared to the learnings it did, then it's also something, it's a kind of a alert candidate. And based on these learnings we did dynamic thresholds. In TV business, as you all know, if it is a very sunny day, nobody watches TV. No, very less people watch TV. But if it is like very cloudy day, snowy day, whatever, people tend to watch more TV. So we had to build our models in a way that this is still working. It's not like, more the consumption, more the alerts, We had to make sure that these kind of things still work when it's when the consumptions go high. Maybe the CPUs or whatever goes also high. Or the error rates goes high. So we had to build up a model which also did the dynamic alerting based on these facts into consideration and don't alert, when the consumption goes high. We also implemented some pinpointing of the root causes, which was with the ML features what we have in Elastic. And what we did there was like drilling down into the problem with the right kind of dashboards we pre-prepared, and with the ML and AI, ML we were able to drill into those problems. And what we also did was like kind of implemented some remedial actions. So we have some automations in place. But when we kind of find these kind of errors, what we try to do is like, in a very simple case, restart a service, which works for 80% of the cases. Or kind of we trigger a restarting with a human intervention. That means the end user gets an email that he just needs to click on approval, which triggers a restart of his service. So these are the kind of things what we have done right now. I don't know if I am just talking and you guys have some questions. If you have, we can do it, or we can do it at the end. All right, so these are things what we did, and we have quite a lot of things we have in our mind. You know, very simple, to put it very simple, this AI ops is a big buzzword. A lot of people talk about it. A lot of people know what to do, and a lot of people also don't know what to do, and what are things we need to identify, and we need to find out what are the possibilities that's there. So this is what we would like to do. So what we also have is like, in our agenda is to do a lot of unsupervised learning. Right now we have tons of logs. We don't know what to do with it, because we need some effort on our side to say, hey, these are the logs, do when the trend is going like this, do something like that. But to go one step further, we say dump all the logs, show us what are the correlations, and we would like to try that unsupervised learning, and we would like to know what all are the possibilities with Elastic and other things in the market. The prediction of capacity, it's very simple. Prediction of capacity in ops is something we would like to try. Of course, IT infrastructure is something we would like to see. We also have done already something in the machine learning, where we try to forecast the consumption of the infrastructure. But we would like to go further with that. Yes, the prediction of the potential issues, like with the predictive analytics. Oh yes, and again, right now in the beginning, when we tried to send out anomalies, the problem was like people used to tell, hey, that's okay, it's normal to have these anomalies. So there was a lot of human intervention or human intelligence involved to say, learn from those things and try to adjust the machine learning to make it happen for anomaly detection and anomaly-based alerting. All right, and this is also one more thing that based on the incidents in the past, we used to learn and incorporate a lot of things in our monitoring things. And the buzzword, the pre-mortem, to enable the detection of the problems even before it happens, is also something we would like to do more and more, rather than having an issue and being working on it. And of course, these are the things what we have implemented in Swisscom entertainment business, only for monitoring. In Swisscom itself, for the TV, we use Elastic also for the recommendation engine. We have an inbuilt, in-house developed recommendation engine, which is purely based on Elastic, and a lot of other things. But this is the area which I'm trying to talk about today, and this is what you saw. I think that's all I have in terms of slides. Oh yes. If you have more questions, please feel free to ask. I hope I can answer. Okay.